Hello dear students, welcome to chemistry classes. In this class we are discussing a new concept, that is the preparation of glycerol from propene. Preparation of glycerol from propene, and we know that the formula for glycerol, and it is a trihydric alcohol with the formula CH2CH, OH, OH and OH. This glycerol is a trihydric alcohol and its IUPAC name is propane 1, 2, 3 triol, 1, 2, 3 triol. Okay. And this glycerol can be prepared from propene, and this preparation method involves 3 steps. Step number 1 involves the treatment of propene with chlorine gas. Step number 1 involves the treatment of propene with chlorine gas, and when this mixture is heated at a high temperature of about 450 to 500 degrees Celsius, we will get CH2, Cl plus HCl. This is allyl chloride. When propene is heated with chlorine gas at high temperature of about 450 to 500 degrees Celsius, we will get allyl chloride. And step 2 involves when this allyl chloride is heated with sodium carbonate at 12 atmospheric pressure, undergoes hydrolysis. When this allyl chloride is heated at 12 atmospheric pressure in presence of sodium carbonate, this will undergo hydrolysis, means addition of water, and forms CH2 double bond CH, CH2 OH. This is allyl alcohol with the formation of HCl. This is step 2. And the last step, that is step number 3. This allyl alcohol CH2 OH, allyl alcohol, when treated with hypochlorous acid, that is HOCl, hypochlorous acid, and we know that this hypochlorous acid is a polar molecule. It has a positive and a negative part. Here the negative part is chlorine, that is Cl minus, and the positive part is OH, that is OH plus, and this addition will takes place on the double bonded carbon atoms, and the addition follows a Markovnikov's rule, and therefore the negative part will add to the central atom, that is the carbon which is having less number of hydrogens, CH, Cl, CH2, OH, and this intermediate when hydrolyzed, that is when undergoes the reaction with water, we will have CH2 OH, CH OH, CH2 OH with the liberation of hydrochloric acid, that is HCl, and this is our desired product, that is glycerol. This is the preparation method of glycerol from propene. This glycerol can be prepared from propene, and the preparation method involves 3 steps. The first step involves heating the propene with chlorine at high temperature. Here we will get allyl chloride, and this allyl chloride on hydrolysis in presence of sodium carbonate gives allyl alcohol, and this allyl alcohol in the next step undergoes Markovnikov's addition of hypochlorous acid, and this intermediate on hydrolysis means the addition of water gives glycerol. Okay. Then the next concept is synthesis and uses of nitroglycerin. The next concept is synthesis and uses of nitroglycerin. This nitroglycerin is also called as a glyceryl trinitrate, glyceryl trinitrate, which we can write in short capital GTN, glyceryl trinitrate, and it can be synthesized by treating glycerol CH2OH OH OH. This is a glycerol, and when this glycerol is treated with concentrated nitric acid, that to 3 molecules of or 3 moles of concentrated nitric acid in presence of dehydrating agents like sulfuric acid at a low temperature at about 10 degrees Celsius, we will get nitroglycerin CH2 CH CH2 O NO2 O NO2 O NO2 and 3 molecules of water, and this one is nitroglycerin. Okay. This is the synthesis method of nitroglycerin or glyceryl trinitrate. This nitroglycerin can be synthesized by heating glycerol with concentrated nitric acid at a low temperature in presence of dehydrating agents like a sulfuric acid. Here we will get a nitroglycerin. Then coming to the uses of this nitroglycerin, the main use of this nitroglycerin is as a explosive material. The main use of this nitroglycerin is as a explosive material, and this nitroglycerin is used as an explosive material in the name of dynamite, and cordite. This nitroglycerin can be used as an explosive material in the name of dynamite and cordite, and the other use of this nitroglycerin is in medicine, used as a medicine. In medical use we can use this nitroglycerin. Here this nitroglycerin can be used to treat chest pain, and here it can be used to control or to maintain the flow of oxygen and blood to and from the heart. This is all about the synthesis and the uses of nitroglycerin. This nitroglycerin is also called as a glyceryl trinitrate, and it can be synthesized by treating glycerol with concentrated nitric acid 3 moles of HNO3 at a low temperature in presence of H2SO4. Here we will have nitroglycerin, and this nitroglycerin can be used as an explosive material in the name of dynamite and cordite, and the other use of nitroglycerin is as a medicine to treat chest pain. And the next concept is composition and uses of dynamite and cordite. These dynamite and cordites are the other forms of an explosive material which are containing a major amount of nitroglycerin. Now only we have discussed nitroglycerin can be used as an explosive material in the name of dynamite and cordite, and here we have to discuss the composition of these two and the uses of these two. The first one is dynamite. In olden days, these dynamite can be prepared by absorbing this nitroglycerin that to liquid nitroglycerin in case agar. In olden days, this dynamite is made up of by absorbing the nitroglycerin, that to liquid nitroglycerin in Kesselgar. What do you mean by Kesselgar? This Kesselgar is a naturally occurring soft and white rocky material, and it can act as an absorbent. Okay. In olden days, these dynamites are made by absorbing the nitroglycerin in Kesselgar, and it was first prepared by Alfred Nobel. It was first prepared by Alfred Nobel. But nowadays this dynamite is made by absorbing nitroglycerin in wood pulp. Wood pulp means what? Crushed pieces of wood, and then mixing with solid ammonium nitrate, that is NH4NO3. Nowadays this dynamite is preparing by absorbing nitroglycerin in wood pulp. Wood pulp means what? The crushed pieces of wood, and then mixing this one with solid ammonium nitrate. Okay. This is all about the composition of dynamite. This dynamite mainly consists of nitroglycerin and wood pulp and solid ammonium nitrate. And coming to the uses of this dynamite, the main use of this dynamite is used as a explosive material, and the other use is as propellant. What do you mean by propellant? This dynamite can be used as an explosive material and can be used as an propellant. Propellant means the material which is used to push forward. And the second one is cordite. And this is also an explosive material, and this is also called as a smokeless powder. This cordite is also called as a smokeless powder, and it consists of nitroglycerin. Here I am writing the composition of this cordite: nitroglycerin plus cellulose nitrate, which we can also called as a nitrocellulose, and Vaseline. This is the composition of cordite or smokeless powder. This cordite consists of nitroglycerin and cellulose nitrate and Vaseline. And here they are using this Vaseline as a lubricant to minimize the friction. Okay. This is the composition of cordite. And now what are the uses of this cordite? The main use of this cordite is used as an explosive material. Okay. And this is all about the composition and uses of dynamite and cordite. And next concept is distinction between primary, secondary and tertiary alcohols by Lucas reagent. Distinction between primary, secondary and tertiary alcohols by Lucas reagent, and this Lucas reagent is a mixture of anhydrous ZnCl2, that is a zinc chloride, and concentrated HCl. This Lucas reagent is an equimolar mixture of anhydrous ZnCl2 and concentrated HCl, and this mixture can be used to distinguish between primary, secondary and tertiary alcohols. Here, when the alcohols are treated with Lucas reagent, that is a mixture of concentrated HCl and anhydrous ZnCl2. Here this ZnCl2 will act as a catalyst and HCl will act as one of the reactant, and the chloride of this HCl will replace the OH of alcohol and forms RCl. This is alkyl chloride, and this H of HCl will combine with the OH and forms H2O. When the alcohols are treated with Lucas reagent, we will get alkyl chloride and water, and these alkyl chlorides are organic chlorides and hence they are insoluble in water. These alkyl chlorides are organic chlorides and hence they are insoluble in aqueous solvents like water, and therefore they can easily precipitate out. These alkyl chlorides can be easily precipitate out and hence can be separated from the water, and the formation of this precipitate during the reaction confirms the presence of alcohol. And here these different types of alcohols react differently with the Lucas reagent, and if precipitate appears immediately, if the precipitate appears immediately, then the given alcohol is a tertiary alcohol. During the reaction of an alcohol with Lucas reagent, if we are getting precipitate after immediate reaction, then the given alcohol is a tertiary, and if precipitate appears after some time, that is for about 3 to 5 minutes, then the given alcohol is a secondary alcohol. If during the reaction of an alcohol with Lucas reagent, this alcohol reacts slowly with the Lucas reagent and forms a precipitate after 3 to 5 minutes, then the given alcohol is a secondary alcohol. And if there is no PPT at room temperature, then the given alcohol is a primary alcohol. If when the alcohol is treated with Lucas reagent at room temperature for about 1 hour, we are not getting any precipitate, means the given alcohol is a primary alcohol, but here we will get the precipitate only on heating, that too for about 1 hour, then the alcohol is a primary alcohol. By knowing the time taken to form the precipitate, we can judge whether the given alcohol is a tertiary, secondary or a primary. If the alcohol reacts immediately with the Lucas reagent and forms the precipitate immediately, then it is a tertiary alcohol. If the alcohol reacts slowly, that is for about 3 to 5 minutes, then it forms a precipitate, then it is a secondary alcohol. And if no reaction is there at room temperature between the alcohol and Lucas reagent, then the alcohol is a primary. But here if on heating for about 1 hour, we can get a precipitate, that is a primary alcohol. Okay. Then why these different alcohols are reacting differently with the Lucas reagent? The reaction between alcohol and Lucas reagent. The reaction between alcohol and Lucas reagent follows SN1 mechanism. SN1 mechanism. This SN1 mechanism means what? Substitution nucleophilic unimolecular mechanism, and it involves two steps. It involves two steps. First one is the formation of carbocation, and the second one is a nucleophilic attack. This SN1 mechanism involves two steps. First one is the formation of carbocation, and the second one is nucleophilic attack to this carbocation, and this first step is the slowest step, and it determines the rate of a reaction. And if the formed carbocation is stable, then the reaction can easily takes place. Okay. Then now here, by studying the structure of these three alcohols, primary alcohol, secondary alcohol, tertiary alcohol. Here I am writing one example for the primary alcohol, CH3, CH2, OH. This one is the primary alcohol. This is primary carbon, primary alcohol. And during the SN1 mechanism, in the first step, the formation of carbocation is to takes place. And here CH3, CH2 plus. This is the carbocation which we are getting in a first step. Primary carbocation, CH3, CH, OH. This is secondary carbon, this is secondary alcohol, and in first step it will form a secondary carbocation, CH3, C, CH3, CH3, OH, and in first step it will form a tertiary carbocation, and we know that if the formed carbocation is more stable, then it will easily undergo in a reaction with the Lucas reagent. And here this tertiary alcohol, this is a tertiary carbocation, this one is a secondary carbocation, and this one is a primary carbocation. And how can we say the formed carbocation is stable or unstable? If the carbocation is having the stabilizing groups, here these methyl groups are there, these are stabilizing groups, means these can donate electrons to stabilize this carbocation. If this type of groups are more in number, then the carbocation is more stable. Here this carbocation is having 3 stabilizing groups, here it is having only 2 stabilizing groups, and here it is having only 1 stabilizing group. Here this methyl group can stabilize this carbocation, and here 2 groups are there to stabilize this one, and here 3 groups are there to stabilize this one. Therefore, we can write tertiary carbocation is more stable than secondary carbocation, which in turn is more stable than the primary carbocation. Therefore, tertiary alcohols will react very easily with the Lucas reagent and forms precipitate immediately, and the secondary alcohols will react with the Lucas reagent for about 3 to 5 minutes and forms precipitate slowly, and the primary alcohols, when treated with Lucas reagent, we can observe no reaction at room temperature, but reacts only on heating for about 1 hour. Okay. Then by knowing the time taken for the alcohols to react with the Lucas reagent and hence to form the precipitate, we can easily separate tertiary, secondary primary alcohols. Okay. And here we can write the reaction between primary, secondary and tertiary alcohols also. For primary alcohol, RCH2OH, this is a primary alcohol. When treated with Lucas reagent, it will form to Cl plus H2O. For a secondary alcohol, CHR, OH, HCl, ZnCl2, this is RCHR, Cl plus H2O, sorry, tertiary alcohol, RCRROH plus HCl, ZnCl2, RCRRCl plus H2O. Okay. And here we are getting this one precipitate only on heating. This by keeping at 3 to 5 minutes, this one immediately. And the reason for these variations is only because of the structure of alcohols. Okay. Thank you.